Well, thank you everyone for being here. Thanks Amber for the presentation and Optics for putting the event together. It's very nice to see so many people interested in Osquery. After the introduction, just mentioning that I've been doing security things for way too long. Currently I work for ABS Global Trading, which we build cryptocurrency exchanges. Former Siemens, IBM, Facebook, Uber, Airbnb used Osquery in all these places since it was created. And you want to reach out, Twitter or GitHub, both work. Anyway, let's just get into it. So the title of the presentation is Building or Scaling Osquery Using Pure Open Source Technology. And that can be so many things. So mostly the things that we are going to be talking now, it's I presume that most of you know and have used Osquery, but I'm going to still do a quick overview of Osquery. I'm going to go through the steps or like the details of the Osquery remote API, which is going to be the basics when you want to build a scalable solution that sits on top of Osquery, in this case a TLS endpoint. I'm going to go through the details of building and scaling your own TLS endpoint. I'm going to show you guys an example of a TLS endpoint that I recently built and open sourced a few months ago. It's osctrl, and then let's go through some conclusions, lessons learned. Now, Osquery. The first thing to mention about Osquery, it's the Osquery I, which is the command line interface. It's basically what you open in your machine when you want to see what's the schema of a table, or if you want to test if a query works, or you want to just basically extract information of your operating system, but using SQL. And also it's the choice, the tool of choice of a lot of hackers, as you can see in the thing. This is just a joke since the very creation of Osquery, but I really like this GIF. Anyway, Osquery I is the tool to run queries in a single host, and mostly when you need to like test things, queries, and all that. But what the next step of Osquery, and basically it's how to be able to do things automatically in a host, which in this case is the daemon. The osquery-d or daemon, it's what it enables Osquery. The binary is the same, Osquery as the service within the system. And then you're going to have your operative system with its users, user services, all the data that it stores. And then you're going to have Osquery-d, which in this case is the daemon of Osquery that is sitting on that machine. And on top of that Osquery-d daemon, you're going to have the configuration that applies and then logging that it generates. Those are the two basic things when you are dealing with Osquery-d. Keeping those two in mind, the configuration and the logging, you're going to most likely be using centralized management, either a backend, it could be many things. We're going to go through all those details. And on top of that, there's going to be some intrusion detection use cases, or in the case of monitoring your infrastructure or compliance. There's so many things that you can do with Osquery these days. So this is basically the usage of Osquery-d for a single host. The problem is that when you will start having a number of machines, you're going to have Osquery-d running in all of those. So you're going to have an n number of machines that are all running Osquery-d, and each of Osquery-d will have its own configuration with its own scheduled queries that they're going to be running at its own interval. So that's going to be generating some data. In this case, that's going to be what we saw in that square, which was the logging component of Osquery-d. Because all those queries are going to be generating some logs. And in the case, in the case of you can have Osquery-d generating logs locally or remotely. If you generate those logs locally, then you're going to be basically writing logs inside of in that computer, and then you're going to need something to extract those logs and then send them somewhere else, because you most likely want to process those logs. That's going to be generating information very valuable about the state and how things are changing within that machine. Solutions that are very, very popular are forwarders, heavy forwarders, could be Logstash, Splunk heavy forwarder. Those are solutions that are very often used for this purpose. Now, if you're not going to have Osquery generating logs locally, you might want to have remote logging. And by default, Osquery can send those logs to either Kinesis, Kafka, Splunk even, or you can implement your own TLS endpoint, and then we're going to be talking about that. What are the steps, the basic steps, both for implementation and from the point of view of implementation and the point of view of infrastructure, because sometimes that is often forgotten. Now, we talk about the logging aspect of OsqueryD. Now, how are you be able to configure OsqueryD to do what you want to do, to run the queries you are expecting to run with its intervals, for each platform? There is so many, the configuration of Osquery can actually get quite complicated. So, same as the logging aspect, you can be having local configuration that you will have to maintain. Most of the times that's done with what is used for IT or infra management. For example, Chef, Puppet, Jamf, Ansible, those tools are the ones that mostly are used for dropping local configuration, and the service Osquery will pick on them. Will pick that up as the configuration, either if it's configuration or flags file. However, there is the other option, which is using TLS endpoint to distribute the configuration of Osquery, which is way faster, and then you can make changes, and your infrastructure will receive those changes way faster. Well, so if you have your IT infra management done the right way, it should be comparable, but we are here to talk about TLS endpoint, so let's focus on that. Right, now we've done like a quick Osquery overview. We talk about the OsqueryI, OsqueryD, the aspects about logging and configuration. Now the part that makes possible to be able to build your own TLS endpoint solution is the Osquery Remote API. It's very, very powerful, simple to use, so it's actually very easy to implement. So in this case, we have, and this is the diagram that most of the times when you are looking for a TLS solution or a system that is going to allow you to both configure and receive the logs from your Osquery nodes, you're going to have a number of machines, could be different architectures. They're all going to have Osquery running on them. They're going to be generating status and result logs, and they're going to be sent over the internet to hit your TLS endpoint, which is the part that we are discussing how to build. And then the TLS endpoint will be able to just distribute the configuration to those hosts. So these hosts will receive the configuration from the TLS endpoint and then submit the status of Osquery and the logs generated by the queries, right? Everything good until here, because this is kind of like one of the simplest diagrams of like remote architectures. Okay, well then, one thing, the Osquery wiki, it's really, really good, and it's being kept up to date mostly, which is, I always refer to it when people ask me a question. I always try to send a link from the wiki, because that documentation is really, really good. So all this I'm going to publish my slides later, and I have links to each part of the wiki that has all that documentation. So that is very, very helpful. Anyway, for implementing that diagram that we saw earlier, basically you have to implement a handler for enrolling clients, one for collecting logs, the one that receives requests to collect information, and what I call extras. Extras could be on-demand queries, file carving, and perhaps if you have like a custom extension or something like that. But that is the basics. It would be enroll, logging, configuration, and yeah, those three handlers. Now, if you go to the documentation, which it explains the remote API of Osquery in detail. In order to implement your handler for enrolling, you will have to like submit a post request. Osquery will submit a pull request to whatever is the path to enroll, and it will have to provide the secret, host identifier. All these can be configurable with either flags or local configuration. Then you can here provide the names of the tables that want to actually accompany their enrolling, like if you want to attach that to the enroll request. So you can actually identify the system that is sending the enroll request, whether if you want to do further checks on that, that's up to you and your implementation. So for enrolling, the only thing you have to do, implement a post handler, receives a request. This is the body of the request. It's in all the documentation. And the response from the server will have to be 200 HTTP with the node key that will identify, it is optional, but it's a good practice, will identify that host. Then Osquery will be able to cache that and use that in subsequent queries. So every time, or subsequent requests. So every time that something is sent to the server, you don't have to enroll it all over again. And if you want the server, if something goes wrong in the server side, you can append the value. Like if you set this to true, then Osquery will re-enroll again. You can configure as well the number of times you want to repeat and all that. Well, that is for enrolling. What about configuration? Configuration is pretty simple. Again, post request to your path to configuration. You provide the node key that you retrieved from the enrolling. That's why it's an important piece. Because you can still configure Osquery to provide the secret every time, but the node key will also, it can also be used as signal, because when the Osquery service or daemon starts, it will enroll. If there is, it will enroll. That it will generate a node key. That is going to be valid until either the local database of Osquery is deleted, or something happens in that box. That is signal by itself. So you can use that to be able to say something happened in that machine. Why there was a re-enroll? If that continues to happen in all your fleet, then obviously something is happening within Osquery. So that is signal by itself. So do not discard those type of events, because they can be very, very helpful. Okay, so request with the node key, and it will just get a response, which is the schedule with all the blob of the configuration. Same, node invalid. If it's true, it will re-enroll. That schedule is the same as if you were to configure a osquery.conf file to load locally. So basically, it has to be a JSON that is well-formed, because otherwise Osquery will just attempt to configure again. So that is where your configuration goes. Okay, we talk about enrolling, configuration. Now let's talk about logs. Here there is two different types of logs that Osquery will submit to the TLS endpoint. You have status and result logs. The request will go, again, HTTP request to the post request to the path to log in your server. It will provide the node key that we discussed before. It will tell what type of log, whether if it's a result or a status. Results is the data that Osquery generates with scheduled queries. Whether status is information about the internal the inner workings of Osquery, whether if it's data submission to the TLS endpoint, it ran an execution, or anything that the client will log locally. So that's going to send to the server. Then you are going to be able to tell what's going on in your Osquery nodes by looking at those logs. And then here is where the data with all the data from those logs is going to be provided. The response, same as the configuration, node invalid. If nothing happens, this is actually I think I don't know if I mentioned that. This can be optional. If node invalid is not going to be true, you can just leave it out. But I don't know. I like to just put it there. Okay, so we have enrolling, configuration, logs. Now, one of the things that I mentioned earlier as extras is the on-demand queries. On-demand queries is some functionality of Osquery that you can enable by having a TLS endpoint, which allows you to run a query as it was run in the Osquery eye, kind of. So it will basically say, I want this query to run now. So there is going to be 2 endpoints to implement for this for the on-demand queries. The first one is what is called the read. Then the request is going to be a post request to the path to query read. We'll provide same thing, the node key with the node that got from the enrolling. And this basically what it makes Osquery is to ask the server, do you have a query for me? If there's no queries, you can just reply with a 200 with a node invalid equals false, and there's not going to be queries. Or you can just have it empty. Because just this would be, you just provide here nothing, and then there's no queries to be executed. Node invalid, same thing, false. This is for the read endpoint, because there is another endpoint for on-demand queries, which is the query write, which is basically once you have provided these queries to Osquery, Osquery is going to collect these, like run these queries, and then submit the results into the write endpoint. That is what is going to receive the actual data that Osquery generates with those queries that you sent. And it will generate, it will take the node key that we've been using in the whole process. It will just give you the results of each of the queries using the ID that your TLS endpoint submitted the client to. And it will tell what is the actual status of execution of that query. So if something isn't 0, then obviously something went wrong, and then you might want to look at the status logs to see what exactly broke. Because those query had a problem, and then it wasn't able to run that query. Okay, so that was the request to the write. Response, same thing, node invalid. If there's no, if everything went fine, you can just skip this step, but it's the same thing as the other endpoints. So we went through the details of the implementation of these handlers. Now we talk about how it should look if you implement the enroll handler, the logging, configuration, and the queries. Now, we talk about the implementation in the server side, but we haven't talked about what is the actual configuration that you have to apply in the client to be able to use those things. And these are not all the flags that Osquery uses for TLS. There is the TLS hostname, the certificates. There is a whole lot of other flags that you can use for this. The secrets, everything that it's, and I will encourage you to just go and look at the remote documentation, because all the flags are there. But I'm gonna mention this because for the next thing I'm gonna tell you guys about, which for the enrolling, this would be like the endpoint, the path to enroll that I showed you before. Same thing for the logger endpoint and the period, because you want Osquery to be sending logs every so often. So this is going to be an interval in seconds that Osquery is going to be sending those logs to your remote server. Same thing for configuration. Endpoint is the path, and the TLS refresh is how often Osquery will make a request to the configuration endpoint in your TLS server. And same thing for the distributed TLS, either read or write endpoint, the two that I show you, and the same for distributed interval. Here is one detail. The distributed interval will configure Osquery for the interval in seconds when how many seconds every request to the query read, because the query write will be sent once Osquery receives a query. So that is not configured, it's just on demand. It will be, Osquery will use that one once there is some queries to send. So we went through the details of the implementation details of the remote API. Now, we are gonna discuss a little bit how to build and scale a TLS endpoint that we just learned how to implement. So basically we have now a handler for enroll, handler for logs, handler for configuration, and then handler for extracts, whether if it's on-demand queries or file carving. What is the next step? So, okay, well, supposedly you are going to have a system that has Osquery on it. And then through the internet, it is going to send the logs to your TLS endpoint that you just built, and it will receive some configuration. So First, it's going to submit the enroll request. Then it's going to receive configuration. It's going to consequently request Osquery for more configuration. Then it's going to submit logs. And then it's going to ask for on-demand queries and will submit the results of on-demand queries. OK, this is cool. You have one machine that is doing that. Everything's great. Now, how many people here use AWS? How many of you use everything, all the tools that are available in AWS at your disposal, like auto-scaling instances, load balancers, all those good things that are there for a reason? Yeah, I know you do, Changyong. OK, so this is very important because when you start adding more nodes, you're going to start having a lot more of requests. And you are not going to, like, this is the component of infrastructure to building your TLS endpoint, because that's when your DevOps people are starting to yell at you and your SREs are getting paged and your production environment is going down and all your assets are having watchdog to kill Osquery because it's restarting all the time, and this is not a great time. So this is one thing that I'm going to discuss now is, in ideal world, everyone would be using the auto-scaling instances and load balancers and all those good stuff. But because those things are not super straightforward to use, or even if they are, like, we are still not there yet. One thing that it would be, like, for example, let's see, let's go to the details of the intervals we just discussed, right? For one machine, you are going to have, in this example, you're going to have the config TLS refresh, 60 seconds, then distributed interval, 60 seconds, and logger TLS period, 60 seconds. That means that every 60 seconds, Osquery is going to be sending one request to your TLS endpoint, this one node that you have, right? Now, that is 3 requests per minute. That wasn't too hard, was it? Like, come on. I mean, this is kind of like, it's super easy to figure out. Right. What happens when you have an n number of nodes, and then you have, and these numbers are kind of easy to work with, like value for the config TLS refresh, and then one value for the distributed interval, and another value for the logger. Then what happens is that you will start making the calculations, and then very soon you realize, well, that is not as easy as just 3 requests per second, because I have a number of nodes, and then I have some intervals that are higher, and these are not S-played, so they're gonna all come at once. So you have to start thinking about how many requests I'm gonna get per minute, per second, because you will be able to answer those questions when you're putting together some production infrastructure. What if you build one TLS endpoint, and in the first hour of being live, you get 15,000 hosts, just like that? Are you gonna be able to take that? By not putting the biggest instance you can ever find and then scale down. That's usually the way, but imagine that you kind of don't want to waste too much money on cloud bills, or you cannot do it for other reasons. So how could you figure out what is an estimation of the number of requests that you're gonna have either per second, per minute, so you can actually plan your infrastructure and be like, okay, well, I think this is the way to horizontally scale and absorb all the traffic and requests that my Osquery agents are going to be sending. So there is basically, this is what happens, right? So in the value that I show you, you're going to have T0 and then 600, which was the highest interval. And then every 100 seconds, you're going to have one query request for the distributed. But also, you're going to have every 300 seconds, you're going to have one configuration refresh. So this is, you have to take these into one request, one request, one request, one request, one request, one request. Here, also another request for configuration. And then at 600, you're going to have another one. And this is for a single machine. When you have n number of nodes, how would be the way to literally estimate how this is going to work? How can I know how many requests per second? This is kind of an estimation with, there's some caveats that I'm gonna go through them in a minute. But basically, what you can do is you take the highest interval, you divide it by each of the intervals, and then you sum all those values. So in this case, you get 600, which was the log, and then you divide it by the 600, which is the highest, then you get 1. 600 divided by 300, then 2. 600 by 100, 6. And then that should tell you that you get 9 requests per 600 seconds period, which, you know, if you divide it, you divide it by 600, it's 0.015 per second. If you have 1,000 nodes, that's going to be approximately 15 requests per second. So now that you know what is the code that you have to write, and you are going to expect 15 requests per second, now you can probably build your infra, or like your product, and plan your infra in a more accurate way. And that's helped to kind of like plan either how your production environment is going to look, or how it's going to be looking. So this is a very high-level estimation, because we didn't take into consideration enroll, which is going to create n requests at T0. N is the number of nodes you have. You're going to have a peak. Now, what about query writes? Because for each of the on-demand query, you're going to have one query write that comes in, right? File carving. We haven't talked about file carving, which has another 2 endpoints in it on block. What about accelerated mode? Accelerated mode is a great tool that is undocumented, and you're going to learn tomorrow more about how to use that effectively in the Mitchell St. Andrews Go Query talk. And those intervals, like I said, those intervals aren't not displayed. So you're going to have peaks. So you have to take this into consideration. So all those numbers that we did, you have to like use that as an estimation. So eventually you will be able to, you will have to adjust that accordingly. But it will be around those numbers. Now, we talk about implementation, we talk about infrastructure. I'm going to show you guys a little bit about the TLS endpoint that I built. It's purely open source. Its name is osctrl. You can find it in GitHub. If you want to use it, feel free to do it. I've deployed this successfully in a couple of companies with running several thousand hosts, and it has been working well. It scales pretty well. I'm not doing the proper cloud auto-scaling thing, so that's what I was talking about. The main idea about OS control, and these are the components, is that you have your Osquery nodes, goes through the internet, and you have the Osquery TLS. It's modular, and it has its components that can be deployed separately from each other. So the Osquery TLS is what is going to receive the TLS endpoint. Usually you want to have this on the internet, so your Osquery nodes will be able to reach to them without VPN. Then you have the Osquery admin the oscontrol admin or API, and that allows you to both administer oscontrol and build tools on top of oscontrol API. Again, tomorrow the Go Query talk, you're gonna see how you can leverage like a proper API, and then it will just generate proper metrics. You will use like a backend for synchronization, has its own CLI. This is basically just the diagram of a network product. Like I said, you can use it for all the good things that a TLS endpoint use, and Osquery you can use it. The API, the remote API of Osquery is simple enough, so you can implement that for other things. If something doesn't support Osquery, you can still implement the remote API, so your TLS endpoint will be still able to receive that. And this is just how the admin looks like. You can join the oscontrol channel in Slack and ping me there as well, or just grab it from GitHub. So now we're gonna see what we learned after these 30-ish minutes me talking nonstop. So basically, I really like open source, and I basically dedicated my life to it, or my professional career. So when people say, well, I don't have the power to build a solution because I don't have engineers, whether if you buy a solution or you build a solution, you're gonna be spending money. So whether you want to spend money on long-term investments, or just, I will buy this product for this year and then we'll see. Either way, you are going to not be able to do it on the cheap side. Or maybe you can, but I don't know. Always plan for the worst case scenario. You know, if you have a high number of requests and then you don't reach that number, that's great because it means that you plan properly. So always plan for the worst case scenario. If you are using cloud, make the most of it. Learn about all those things, the load balancer, the auto-scaling instance, all those things are there for a reason. And once you have logs, don't forget them. Don't just leave them there and then never look at them because there is information in those logs that I want to utilize for either monitoring your fleet or for incident response, for compliance. There is one thing which is very important. For open source, sometimes there's things that aren't documented. But you have to go into the code to find out what they do. So in this case, I'm going to let you guys to find out what the accelerated mode and file carving, because those two are not in the remote API and still very powerful. Thank you.